Hello, folks. So, we are going to continue talking about C groups, control groups. So, I'm trying to create a plan. Actually, my colleague already created a plan to understand how we can ensure that our softwares support C group V2, control groups V2. So, as part of C group version 2, we have uh, basically we are running Kubernetes and we have a lot of applications written in like say Java, Node.js, and JavaScript, which is running on Node.js runtime, and then Golang. I think mostly these three. So my colleague wrote basically what we can do in terms of like understanding compatibility. For example, we have already found out that which versions are compatible with control group version 2, which versions of the language runtime, depending on Java or um, Node.js or Golang. So yesterday I was looking at Golang mostly. So yeah, I mean this was mostly talking about this Michael Pratt. So I think this guy is building these two things, Go and gvisor. Um, so okay, just a minute. Anyway, so we are looking at uh, how in Golang the program, the software, the runtime basically is aware of the container, aware that it's running inside a container, and is aware of the limit on the resources that it has access to. Limit on the resources, which is CPU, memory, mostly these two, though there are other things like network, storage, disk, basically. Yeah, so in this case, so I was looking at Golang runtime and how it is container aware. So looks like this is the one proposal which talks about the whole thing, and the actual issue that brought this up was this one, right? This has been created just recently. This was in 2019, so 6 years back, right? And this person talks about Uber's Automax procs, which is a library that Uber folks have written for Golang. So they have a separate organization for Uber Go itself. Apart from, I guess, Uber has its own open source stuff. So weird that this is also written in Golang, but they didn't put it in their Uber Go thing. Anyways, so so I was reading through the code of this Automax procs on how it actually sets the GoMax procs automatically, and I noticed that there's quite some logic in it. So Yeah, I mean, there is some logic here also. So in the runtime and the C groups thing, so maybe getting into this repo might help to understand, like opening this repo locally and trying to understand what's going on. Let me see if I can do that. Um, Let me just use HTTPS. Cool. So this I can open it up in VS Code and enable Golang in it. Golang extension and start opening up stuff here. So I think there is a package file.go at the top level, automaxprocs.go. So if you go through the set, you'll notice that this is the thing that's getting called, and they have this thing called iRuntime, which you can actually open it up here, or you can just go here. Right, so they have this and this. So there are only two files here, I guess. The other one is test. Okay. So if you look at this, this is basically this. It says -1 and then CPU quota undefined and all that. This is for Linux. This is also for Linux. Weird. So there's this versus just a minute. I wonder if this is the same thing. Yeah, how come? What does this point to? This. Okay. And what about this? So this is unsupported. If it is not Linux, it will go to this. Okay. So this is for not Linux. I think in my case it's not Linux, that's why. I have to set it up as Linux, then it will come here. So this is for Linux only. And that's why it's called unsupported and all of them. So current process. New C group, okay, returns the CPU quota plan. Proc path mount info, okay. Okay, so this is for I think V1. It doesn't say V1, but I guess this is mainly for V1, I think, and it's only for Linux, of course. This is also of course for Linux. What's the difference? C group versus C groups. Reference is C groups V2. The mount point for this looks like it's this FSC group. This is the mount point that I've always noticed. But for C group V1, there is a proc path movement. Mount point. Okay, C group point mount. Interesting. This is the for Linux control group. Okay. So this is param path. Given the parameter, the path and the parameter, so the file path join. Okay. Who uses this? Read integer. They use it. Okay. Parameter name CPU dot cfs quota us. Okay. Looks like they've done quite some stuff. I need to understand how even Kubernetes and Docker work with control groups. Maybe I need a primer on control groups to understand what is going on here. And there's not much here. So disagree with some of the later destinations and like using seal quota plus or linear over provisioning commands stocks versus CPU quota. This address is statistically gamble to ameliorate current shortcomings in Go so user space scheduler. It's the same person basically. They're talking about some disagreements. Some background changing from seal quota to floor quota. Floor is the math floor, like the lesser value, the least, the smallest integer, which is the greatest integer, which is smaller than the current value, is floor, versus seal is, I think, the smallest integer which is greater than the value. So seemed reasonable. And the guess was if we provision fractional cores, we use them. So they over provisioned before. They end up needing fractionals to add margin for other supporting processes injected into a container. Example, Misos Aurora as Thermos executor. Okay. Okay. So you have a quota set to n plus p for some integer and some p. Next assumption then is that you're using p value as a hedge for something like system effects or C libraries. What do you really want to do is like some k of CPUs stolen for some parasite like a C library or sidecar, but this will always need to be application context specific. Okay. Looks like this is for the Java support that we also noticed. Is it cgroups v1? Is there okay. Wow, there are so many other people who have actually referred to this, I guess. So it looks like Ruby also had this. Then a number of other issues appears linking to this issue using Uber's autonomous audio. And this is something the community clearly wants or needs. This is a good question. Not too much more. Looks like a lot of people spoke about this, and finally, someone had a. So I think this, yes, we do have to check it out. Go containers and the Linux scheduler. So like many Go developers, my applications are usually deployed in containers and running in container orchestrators. In container orchestrators, it's important to set CPU limits to ensure that the container doesn't consume all the CPU on the host. Is not aware of the CPU limit set on the container, it will happily use all the CPU available. First, leading to high latency. In this blog, I'll explain what is going on and how to fix it. So this is going to be a pretty high level overview of the Go garbage collector GC. For a more in-depth review, I recommend reading the Go Docs in this excellent series of blogs by Will Kennedy. So Will Kennedy is a popular Golang expert, and he does training for Golang. So the vast majority of the time, the Go runtime performs garbage collection concurrently with the execution of your program. So when your program is executing, concurrently it will actually just do garbage collection, which means trying to do two things, but usually one at a time, unless you have more cores. This means that the GC is running at the same time as your program. However, there are 2 points in the GC process where Go runtime needs to stop every Go routine. Okay. This is required to ensure data integrity. Before the mark phase of the GC, the runtime stops every Go routine to apply the right barrier. This ensures no objects created after this point are garbage collected. Okay. This phase is known as sweep termination. After the mark phase has finished, there is another stop the world phase. This is also popular, I think, in JVM or any garbage collected language. So this is known as mark termination, and the same process happens to remove the write barrier. It usually takes in the order of tens of microseconds. Okay. I created a simple web application that allocates a lot of memory and ran it in a container with a limit of 4 CPU cores with the following command. Code for this is available here. Go CFS blog. So interesting. That's all you need to do to build it and get an image out. Okay. It's worth noting that the Docker CPU limit is a hard limit. You can set CPU shares, meaning it's only enforced when the host is CPU container constrained. So this means that the container can use more than the allocated CPU cores if the host has spare capacity. It's only enforced when this host is CPU constrained. Okay. But if the host is constrained, then the application will be limited. You can collect a trace using the runtime trace package and analyze it with gotool_trace. It shows a GC cycle captured on my machine. See termination and want to stop the world trace on proc file. STW, okay. Mark assist. This is GC. Proc 5. Yeah. Stop the world is here. Where else? Can't see stop the world anywhere else. Okay. Okay, the GC cycle took just under 2.5 milliseconds, but we spent almost 10% of that in a stop the world phase. Okay. This is a pretty significant amount of time, especially if you are running a latency sensitive application. Okay. The Linux scheduler. The completely fast scheduler was introduced in Linux 2.6.23 as the default scheduler until Linux 6.6, okay, which was released last week. It is likely you're using the CFS, okay. So completely fast scheduler, okay. So I do have a Linux machine here. I wonder which one I'm using now. So name, I think I'm using 6.8 and I need to check which scheduler I'm using, okay. So, and is the desktop process scheduler implemented by Ingo Molnar and what is replacement for the previous vanilla scheduler shed other interactivity code or EA for this documentation can be summed up in a single sentence. Basically, models are ideal, precise, multitasking CPU on real hardware. Okay. RB tree is that red black tree? What's an RB tree? I don't know. Completely fast scheduler in Linux. Red black tree, okay. Looks like it's the red black tree only. Red, yeah. Red black trees, okay. Okay. I think I have quite some stuff to look through. Mainly this for Golang cgroups v2. Golang cgroups and cgroups v2. Okay, and then I'll look at this. this, and then we have this, and then we have this, and then we have this GC guide. I will come back to these later. Cool, there are quite some things. I also noticed, I think yesterday we saw something about here, right? Like, I think this one, which clearly said it referred to many, articles. Container throttling problem. For the love of God, stop using CPU limits. Go containers in the Linux scheduler. Apply the resource requirements. So CPU throttling. I think there are quite some stuff to look at. I'll look at it one by one. This was on. Okay. Interesting. Anyways, this is what I'm looking at, River Phillips thing. So this we already know, and I think that's it. So max procs and this and this and this. And then this. So the CFS is proportional. It's a proportional share scheduler. Okay. We need to understand if we are using CFS. In our case, we plan to use Amazon Linux 2023. So we need to understand which version of Linux they're using. Amazon Linux 2023 GitHub. So you look at this. Let me get the code for this. Amazon Linux, okay. Amazon Linux. I wonder what other projects they have. Container images, utils, Linux. This guy is a contributor to the Linux kernel, I think so, yeah. Let's look at this for now. Let me look for anything that says version. There are a lot of places where it says version, okay. Let me open this up in code. And release notes for 2023 0222. 2023 09, okay. Name is this 2023 0809. This is what we're looking at. Release notes. So I think release nodes, Amazon Linux 2023 dot 2 dot 20. Okay, I think this is the one because the others are 0, 1, and then this is the 2, so this must be the latest. So I wonder what version of Linux they're using here. Kernel, it's 6.1. Okay. Let me look at this also. Support statements, release nodes.md. Kernel. Launching the latest via CloudFormation. Okay. Kernel 6.1, 6.1. Okay. Configuration, kernel, Linux. It's hard to find out support statements. Okay, I'm guessing this is not something that we need. I'm wondering where is all the code though. This is all release notes. Quick links, learn how to get started. Does it have any other parameters? 2022, okay. Weird. This is just the release notes, is it? So is built from the same software components that are included in the. It's available for use in any manner as a base image for Docker workloads if you're using Amazon. So I think we have Amazon Linux over here. So actually this is one of the things that you can actually see in their org that they have container images. I'll just get these. It's also here. So if we look at the Docker file, I think we should find out where is what is where and all that. AL 2023 ARM64. Okay, let's get this one out. So readme.cloud.net kernel over not loaded in container images, okay, as not tarball exactly, but tar.c. Maybe I'll just get into this and see, maybe quick branch, FNA. That's a lot of branches, so can't. So 2023 ARM64 and maybe with sources is something that I can check out. Actually this one. Yeah, let's do this and Docker file. There's Alpine latest done. So it has kernel Linux. Okay. So it says root fs. Oh, it uses this just like the start, and then copies from scratch as root from verify. Okay, so they do some verification, so they basically get the tarball from here. So let's download this and let's see it comes up properly. So it is here. If we open up, I think you should be able to find something in the downloads over here. Okay, so let's get in. Oops. Okay, so here, how do I know what is the version of the kernel now? And kernel Linux kernel version. Uname -r -a proc version. Okay. Let me try out proc version then. Downloads this proc. There's nothing in proc. Great. Maybe I'll just run the container and we'll see. Docker ps7. This has been running for some time. Let's get rid of this. Okay, Docker run Amazon Linux bash. If it has bash, maybe we'll get bash, or it's pretty small. So also has shell. Okay. So uname -a. This is 6.8. Okay, so are we using this only? I need to check it out in our machines. We are using AMD 64 machines, I think. So if it's 6. So this was the default, and in this, what is the scheduler? Linux kernel scheduler information. Get. So identify the currently active IO scheduler. Okay. Default CPU scheduler. So primary schedule for CPU time allocation among processors. It aims to provide an source code. Okay. But I think this changed. This this for which version though? So something to learn about later. Okay. Proc command line. Okay. It says I think we can check it out by so from 6.6 has been replaced by the earliest eligible virtual deadline. Okay. Okay, so anything above or equal to 6.6, it's earliest eligible virtual deadline first. Okay. Hmm. Everyone has been referring to completely fat scheduler. Hmm. It's okay. We'll get back to it. For now, we'll assume, let's say we have CFS and let's see what people are talking about it. It's a proportional share until this was released last week. This was in 2023, so so it's likely you're using that. The CFS is a proportional share scheduler. Okay. And this means that the weight of a process is proportional to the number of CPU cores it's allowed to use. It is allowed. For example, if a process is allowed to use 4 CPU cores, it will have a weight of 4, and 2 CPU cores, it will have a weight of 2. Based on the weight is proportional. This CFS does this by allocating a fraction of CPU time. Has 4 seconds of CPU time to allocate every second. Okay. So when you allocate a container number of CPU cores, you're essentially asking the element to give it n CPUs worth of time. I'm asking 4 CPUs worth of time. This means that the container will get 4 seconds of CPU time every second. Problem: when the Go runtime starts, it creates an OS thread for each CPU core. Okay. Any C group CPU limits, the Go runtime uses these OS threads to schedule Go routines. Problem is that Go runtime is not aware of the control group CPU limits and will happily schedule Go routines on all 16 OS threads. This means that the Go runtime will expect to be able to use 16 seconds of CPU time every second. Long stop the world durations arise from the Go runtime needing to stop Go routine on threads that it's waiting for the Linux scheduler to schedule. Will not be scheduled once the container has used its CPU quota. Okay. Go allows you to limit the number of CPU threads that the runtime will create This time I use the following command. Below is a trace captured. Now with the governor. Stop the world. There was GC happening, but okay. This days the garbage collection is much shorter despite having this exact same load. Cycle took under 1 millisecond and stop the world there was 226 microseconds, approximately 1/10 of the time, and there was no limit. Okay. Should be set to the number of CPU cores that the container is allowed to use. If you are allocating fractional CPU round down, unless you are allocating less than 1 CPU core, in which case round up. So let me just calculate. If you find it easier, Google has open source library to calculate this value for you from your container cgroups automatically. Interesting. So they are finding out the control groups. What I do, I need to understand how control groups work then, because I thought they just can't. The container just cannot use more resources than it's been given. There's an outstanding GitHub issue with the core runtime to support is out the box, so hopefully it will be added eventually. It's important to set CPU limits. It's also important to ensure that the core runtime is aware of these limits by setting a sensible. Okay. Cool. Okay, so I think at a high level, I'm gonna just do one thing. Just I'm gonna write down a plan. Simple plan for cgroup v2 support. Understand what kind of support the language runtimes provide with respect to cgroup v2. Okay. CPU, RAM, container awareness, CPU limit awareness, RAM limit awareness, anything else? Which Linux kernel version are we using as part of Amazon Linux 3, which is Amazon Linux 2023. So, and this helps understand which process, which process scheduler we're using, and then of course communicate to the teams this first. Find the language runtime versions we can use for cgroup v2 support. Find an alternative to run the language runtime, the old language runtime version, which does not have cgroup v2 support. In a cgroup v2 environment. For example, by passing parameters to the language runtime about CPU and RAM limits. For example, JVM has this feature, Golang runtime also has this feature. Okay, so this too, and then finally if there are no supported official images for some of the components used with the appropriate language runtime version, then build the image ourselves and maintain it. Focus to avoid changes like even version changes and language runtime version and in any component version of Elastic, etc. So we have Kafka here, Kafka, Elasticsearch, etc. Or even it changes like sometimes even minor version changes can be big changes if there are any breaking changes. Unexpected in semantic version. This is valid according to version rules, but some softwares do it. And to ensure standardization in language as much as possible, runtime version in component versions and distribution like Java distribution. Yep, so I think that's it. A lot of articles around how Golang doesn't work well with doesn't work well with CFS scheduler when it does not have cgroup P2 support. And let's check support, and also does not to set the CPU and memory units. Tangential. Notice how setting CPU limits is not a good idea. If you are doing this, check this out and consider if we should continue doing this. And setting CPU limits. Okay. Okay. So that's the simple plan. And confirm the versions. I think this is already done by my colleagues, but we'll have to confirm it. And yeah, basically this is what was mentioned by my colleagues. So update docker files and whatnot. And them by changing the container images. Use in container images. Cool. So I do need to understand how it works for Java. So how Java supports cgroup v2. For example, for Java, I remember looking at this. I'll probably get back to this afterwards. For now, I think this is the simple plan I'll follow, and yeah, I do have to understand how Node.js and Java does things. For example, I could actually check out how Java does things by just running a Java image. Should I try out Amazon Corretto? Dash docker.com Amazon Corretto. CORRE PTO. anyways, it's pulling in. Let's see which version of Java it pulls in. So it has some 120 MB, I think. Cool. Java version is okay. Okay. Hell. I think it's this hyphen version. So 1.8, and this is 1.8, 472. And 472 has support for cgroup v2, but my colleagues wanted to run show settings system. Interesting. Hyphen X, this is for the JVM words, basically. Show settings colon system. So this one says, yeah, cgroup v2. Yeah, so this should tell us if it's cgroup v1 or cgroup v2. And if you get a lower Java version, will it work? Let me try that out. Amazon Corretto. And let me see if I can get an older version. 8U. If there is, okay, there's 472. .462 till the last 252. Okay, there's 192 also. Let me try out 192, just like that. 8U 192. Okay, they don't have it for ARM 64. Okay, 292 they have. Okay, so 292. Let's see if that works. Yeah, it works. It's again 120 MB. So there's 292, 262 and all that. 252. Java version. Just have to say this, I think. Show settings system. No metrics available for this platform. Interesting. So it just says no metrics available for this platform. I think in Java, .372 we got it. So let me see if I can find 372. 372. This is 372, right? So there's 342. No metrics available. So it's actually for 372, okay. 362. Interestingly, here alone it says memory limit is unlimited and all, soft limit, list of processors, total. Interesting. Nothing available. I think 372 is when they started off the whole thing. Page 8. Yeah, 372. Cool, so that's the first version that shows the cgroups v2 in all of this. Um, yeah. Okay. So I think now I can just go ahead and check the same for Node.js. I think here they mentioned that for Node.js it's Node. I wonder for Golang how do you check it out, but for Node, just say run cmd, I think, not cmd. Node hyphen e. Okay, let's see if that works. There's nothing for Node.js. Is there Node? Yeah. So bash. Let's get the latest and let's see how that works. It's gonna be pretty way long. Yeah, it's gonna be big. Recent tags. Okay. If you're running Node 12.14, it's a problem. Okay. Let's check that out. Okay. Oh, so I just need to keep size limit. Okay. Let me get this unexpected thing. Okay, wait. Oh yeah, there's an extra thing, is it? Yeah. Okay, let me try this out. And this. Okay. I wonder how this is different from the limit. Okay, should I mention some limit here? Maybe. What is this heap size limit? Docker health memory in bytes. Let me just give 1000 bytes. Let me say 1 MB, so 1000 bytes is 1 KB. 1000 plus 1000. This one was bytes. It's 1 GB. Let me try that out. Minimum memory limit is okay, so let me just give 20 MB or 100 MB. Okay, 100 MB. That's low, I think. Bytes. Yeah, it's 271 megabytes. Interesting. How much did I give? I thought this was in bytes. 100 megabytes. Yeah, I gave 100 megabytes. It is pretty high, but it's able to set it up. But if I use an older node version, like that's not supported, like 12, then we have 12.14. .0, okay. Let me just use that. 12.14.0. Let me see how it comes up. That's a high value. I do something wrong. Unexpected dots there, okay. I think it works in a newer version but doesn't work in an older version, because I did put the same thing here and it worked. Okay, so shouldn't have put the dot. Let me just say this. You don't understand what that means, but anyways, this is still high. Let me just check how much in bytes is this. Bytes. 1 gigabyte, yes. Even if I set some limit, it's not working out. And if I set 100 MB as limit, hmm, 50, 1, 2, 3, 4, 5, 6, 7, 2, 3, 6, 50 MB. this is bytes, 271 megabytes. Okay. Can I do not 5300 megabytes or 400 megabytes? 1 to 3 kilobytes, megabytes. It's still the same. Interesting. Bytes. I think this is like a minimum that it takes up. And for CPUs, if I say 1, does it take it as 1? Yeah, it does take it as 1. So yeah, I think 25 or 20 will do good. Let's see. Anyways, but that's all I had for this video. Trying out some stuff with Node.js 20 plus 20.3 plus. Okay. So I think the old ones will not be providing these values. This one, I think I just have to say CPUs.length. This is 2. 20.3 20.3.0. Let me just say 20.3. I don't think it will work. It will fail. .0. Oh, how it works. So they did have just 20.3 also. Interesting. Let it run and then I'll try it out with just .0 also, and then I'll try with something older, let's say 19 or something, to see how it comes up. What kind of syntax is this? I have no idea. It shows 2. That's wrong. This shows, okay. Interesting. 20.3 is different, 20.3.0 is different. I think 20.3 gets the latest. That's why it's working. So it is working. Oh no, it's not working. It says 2 though. Interesting. We will try that out. We will write this. I think there was a problem in the download, so this is getting stuck, by the way. For some reason only this is getting stuck. Okay, let's see if it works. Or else I'll just try some older versions also. Let's do this here. 20.3. I want to actually try out this. It says 2. Interesting. It has been saying the same thing since quite some time. Can I just take 10 off and just see what happens? It's still the same. Need to understand what that means and if it really makes sense. What about an older version? Say 19 or something. 20.2 or something. And 20.3 doesn't work. 20.4? Seems like there's still a problem. Gotta check out which version of Node.js actually supports stuff because I'm seeing some variable answers. We need to dig through this. Anyways, cool. So that's all I had for this video. I'll see you in the next one. Bye.